Ever wondered why it's crucial to measure carbon dioxide in flue gas? Well, flue gas, the byproduct of combustion processes in the oil and gas industry, is a significant source of carbon dioxide, a greenhouse gas that contributes to global warming. By measuring the levels of carbon dioxide in flue gas, we can gain critical insights into the efficiency of combustion processes. This information is vital for optimizing these processes, reducing fuel usage, and minimizing environmental impact. Moreover, understanding the carbon dioxide content in flue gas also helps in complying with environmental regulations. Governments worldwide are tightening their emission standards to combat climate change. Hence, regular monitoring and control of carbon dioxide emissions become imperative for industries. But it's not just about compliance or efficiency. It's about responsibility. Responsibility towards our planet. Responsibility towards future generations. Understanding the measurement of carbon dioxide in flue gas is not just beneficial, it's essential. Now, measuring carbon dioxide in flue gas isn't as simple as it sounds. It's a process that requires precision, technical know-how, and the right tools. So let's delve into the nitty-gritty of how exactly this is done. First off, we need to extract a sample of the flue gas. This is typically done using a probe that is inserted directly into the flue stream, which traps a sample of the gas. It's important to note that the sample must be representative of the entire flue gas stream, so the probe is often moved around to different locations within the stream to ensure a comprehensive sample. Once we have our sample, it's time for the main event, the actual measurement of carbon dioxide. This is achieved through a process known as gas chromatography, which separates and analyzes the various components of the gas sample. In this process, the sample is passed through a column filled with a stationary phase. The components of the gas move through this column at different rates, allowing us to separate them out and measure each one. The carbon dioxide in the sample is then detected and quantified using an infrared detector. Why infrared? Well, carbon dioxide absorbs infrared radiation at a specific wavelength, which allows us to detect its presence and determine its concentration in the sample. Now, as you can imagine, this process isn't without its challenges. The equipment must be calibrated correctly to ensure accurate results. The sample has to be handled carefully to avoid contamination. And even with the best equipment and techniques, there's always a margin of error that must be factored into the results. But despite these challenges, the importance of measuring carbon dioxide in flue gas cannot be overstated. It's a vital part of monitoring and controlling emissions in the oil and gas industry, and plays a crucial role in our efforts to reduce the impact of these industries on our environment. So as you see, the process is quite complex, but the results are well worth the effort. Let's recap the essentials about measuring carbon dioxide in flue gas. In the vast and complex world of the oil and gas industry, measuring carbon dioxide in flue gas is a task of paramount importance. It's not just about checking a box or fulfilling a routine operation. Rather, it's about ensuring the efficiency of combustion processes, optimizing energy production, and mitigating environmental impacts. The process, as we've seen, is intricate and requires meticulous attention to detail. It starts with the extraction of a flue gas sample, which must be done with care to avoid contamination or alteration. This sample is then analyzed using specialized equipment, such as infrared sensors or chemical absorption systems. The data obtained from this analysis provides crucial insights, not only about the levels of carbon dioxide, but also about the overall performance of the combustion process. However, it's not all smooth sailing. Measuring carbon dioxide in flue gas comes with its own set of challenges. Equipment malfunctions, inaccurate readings, and even the inherent dangers of working with flue gas. These are all potential roadblocks, but with the right training, the right tools, and a comprehensive understanding of the process, these challenges can be effectively managed. What's more, The insights gained from measuring carbon dioxide in flue gas have far-reaching implications. They can help identify inefficiencies in combustion processes, guide decisions about fuel selection, and even contribute to global efforts to reduce greenhouse gas emissions. In other words, this process is not just a technical task, but a key component in the broader context of energy production and environmental stewardship. So, as we reach the end of our journey through the intricacies of measuring carbon dioxide in flue gas, let's not forget the big picture. Whether you're an engineer, a technician, or simply someone interested in the oil and gas industry, understanding this process is vital. Remember, measuring carbon dioxide in flue gas is a critical process in the oil and gas industry, and understanding it can make a world of difference.